Yeah, we came up with this actually quite early when CANopen FD was specified, because as we all know, one of the early things that was decided is that we don't have to make it backward compatible. And as we cannot run regular classic CANopen nodes with CANopen FD frames, they can not operate on the same network. And one of the logical first solutions to such an idea and scenario is, well, could it be possible to use a smart bridge that on one side talks CANopen and on the other one talks CANopen FD to provide such a bridge in a way that both the CANopen nodes as well as the CANopen FD nodes do not really realize that they are not that they are talking through a bridge. And it's not possible all the way down, but there's quite a bit you can do with it. And so the original challenges, of course, we had is the frame incompatibility, so that we cannot run the same CAN-FD frame on a pure classical CAN network. And also one of the challenges with bridges is always the configuration. Now here we also wanted to see if we can get away with a smart bridge that just by listening to the traffic can configure itself, so that we do not really need to start a lengthy configuration process for such a bridge. Of course, there are some existing specification when it comes to bridges. Here they are just, some of them are listed just for reference. As I said, we really try to, in this system, try to implement it in a way that both the CANopen classical side and the CANopen FD side of the communication are not aware of the bridge at all. So, of course, we have to make a few compromises. And one of the compromises we have to make something like this work is that we define the entire network to be a single virtual CANopen or CANopen FD network. So we still stick to the limit of 127 nodes and 127 unique node IDs. So by introducing a bridge, we do not allow that the same node ID exists twice on the system. Otherwise, immediately it gets much more complicated. So possible scenario setup could be that we have a classical CANopen segment with nodes 2, 7, 11, and 12, and that we have somewhere a CANopen FD segment with additional nodes. But again, we make sure that none of the node IDs are duplicated. So within the system, all node IDs are still unique. Yeah, in this case, we can now introduce a smart bridge that communicates to one side as a classical CANopen node and to the other side as a CANopen FD node. However, we still need to have a node ID also here for the smart bridge. So here in this case, we've chosen 9, and I'll show you a little later in some of the exchange protocols how that actually works. The nice thing is, as I said, by just listening to the traffic, to the network, there's quite a bit that a smart bridge can learn. Of course, once we fire the system up and assuming the bridge is one of the first devices to start, or it is ensured that at some point there is a NMT reset so that everybody restarts, then of course we immediately know on which side of the bridge is our NMT master. Is that on the classical side or on the FD side, depending on from which side we get this message. And by listening to the boot up and potentially heartbeat matches, we also get the location of each node on the system. So if we go back to the previous slide, the bridge, by listening to the messages and boot ups, will pretty quickly get a picture of which nodes it has connected on which side of its port. Of course, once we introduce an active scan and allow the smart bridge to also actively use USDO and other protocols, then we can learn much more. But that's really, depending on how far you want to take this concept that I'll show you soon here.